Yeah, hi everybody, and once again, welcome to Pankaj's Echelon Tutorials. In this today's session, we are going to uh, go for the solution of this particular paper. This is the checkpoint paper of October 2016, and the paper number is 111202. Okay, so this is that paper number. It's of October 2016, right? And this is paper number 2, mathematics, right? And the duration is 1 hour. And okay, calculator you can use in this particular paper, right? Because this is paper 2. So the maximum mark for this paper is 50. Okay, fine. So let us get started with this paper. So I think in this particular paper, from question number 1 to question number 20, I have already solved in two separate videos. This is the third video in continuation of those two videos. Okay. So now today I am going to start with the question number 21. Okay. In this paper, there are total 28 questions. So today we will be doing 21 to 28. There is some 8 questions we'll be doing. Okay. So I'll take you to the question number 21, and here we go. This is question number 21. Okay. So let us get started. Question number 21 says that here is a relationship involving powers of 7. So 7 raised to x into 7 raised to y is equal to 8. This is the relationship given. X and y are positive whole numbers, each greater than 1. So write down the possible pair of values of x and y. So applying the rules of exponents, the multiplication rule, you can write here x plus y is equal to 8. And the condition given is both x and y are greater than 1, isn't it? So what are the possible values of x and y? So you can take the values of x and y as say if you take x2, then from the total to be 8. So this is x, this is y. So if you take x2, your y has to be 6, so that the total is 8. Then if you take x3, your y has to be 5, so that the total is 8. That way if you work out, so x values you can get 2, 3, 4, 5, 6, 7. You cannot take 8, because if you take x value 8, the y value has to be 0. And the condition is both x and y should be greater than 1. So the x values will be 2, 3, 4, 5, 6, 7, and the y values will be 6, 5, 4, 3, 2, and 1. Okay, so these are the different x and y values. So x values and y values you can write this way. You can write x values as 2, 3, 4, 5, 6, and 7. Okay. Uh, 7 also you cannot take, because if you take 7, this should be greater than 1. Okay. So you cannot take 7 as well. Okay. 7 you cannot take, because x and y should be greater than 1, not equal to 1. So these are the values of this thing, that is x, and the y values will be again, I'll write the corresponding values. Okay. So when it is 2, it has to be 6, comma 5, comma 4, comma 3, comma 2. Okay. Okay. So 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6. And this will be 2, 3, 4, 5, and 6 in the reverse order. So these are your answers. Okay. So either you can write the answer in this way, or you can write in this way. Okay. Now, next question. A is done. Now 21b. Here is another relationship involving the power of 5. So here, applying the indices rule, this will mean that m minus n is equal to 4. Okay, this is the quotient rule in indices. So m minus n is equal to 4, and the condition is each m and n must be greater than 1. Okay, so m and n should start with 2. Now m minus n is equal to 4, so this indicates that m is greater than n. Okay, because if m was smaller than n, then this would have been a negative number. Okay, so m greater than n is also the condition. Okay, so we can start with m is equal to 2 here also. Okay, but if you take m is equal to 2, Yeah, n will, you will not get any number n, so that m minus n will work out to 4. Okay, so if you take 3, again you won't get any number which works out to 4. So your n should be some, your m should be something which is which you know, on subtracting n from it should give you 4. So suppose I take m is equal to 6. Okay, then 6 minus 2, because m and n both I should be taking greater than 1. So I'm taking 2 for n. So 6 minus 2 will give me 4. So this is one of the answers. So m is equal to 6 and n is equal to 2. 6 minus 2 is equal to 4. Now there is one more combination. Suppose if I go for m is equal to 14, okay, and n is equal to say 10. So 14 minus 10 again works out to 4. So this is another option. So I can go for 14 and 10 as well, right? So there are two answers for this, 6 and 14, and 2 and 10. For m, 6 and 14; for n, 2 and 10. That was question number 21, A and B both done. Now let us move on to question number 22. Now here he is telling you that the table shows the mass of a child of different ages. So 5 age, the mass of the kilogram is, mass in kilogram is 18.36, the mass is 20.37, 22.68, 25.3. From the age 8 to the 9, from the age 8 to age 9, the child's mass increases by 12%. So calculate the mass of the boy at the age of 9. So calculate the mass at age 9. So mass at age 9 will be equal to, at age 8, the mass is 25.3. So that you have to take plus 12% means 12 upon 100 of, means multiplication. How much? 25.3. So this will be the age of the boy when he reaches the age of 9. This is his age when he was 8 years old, and this is 12% of the age when he was 8 years old. So this calculation you have to do. So 25.3 plus this you can write as 0.12 into 25.3, and this, if you work out, it should come out to 28.336. Okay, so the answer is 28.336 kg. Is that clear? Now B part is calculate the percentage increase in the mass from age 5 to 8. Now percentage increase is given by this formula, increase upon original times 100. So what is the increase in the age from 5 to 8? The increase in the age from 5 to 8 is 25.3 minus 18.3. This is the increase upon original. Original means from where it has increased, from 18.3. The age, the mass is increasing from 18.3. So original mass is this, 18.3 times 100. Now this should work out to 25 minus 18.25.3 minus 18.3 is 7 into 100 upon 18.3. This is 700 upon 18.3, and this should work out to around 38.25. And now you'll have to put a percentage sign. So the answer will be 38.25. Right? So that was question number 22. Now let us go on to question number 23. So question number 23 is over here. Yeah. Now here he says that 40 children are in a running club. They run a 400-meter race in the month of April and again in the month of July. The running time as shown in the frequency diagram is here. So he has given you a frequency distribution table for the 2 months, that is April and July. Okay, and you have to answer these questions. So question number 1 is, put a ring around the month in which the children run the race more quickly. So you'll have to put around which month the race was run more quickly by the children. Okay. So looking at this, and of course you have to give reasons for your answer, right? So let us see. Now, in this particular April graph, you can see that the total number of time goes up to 90 seconds. Okay. So the race goes up to 90 seconds, right? And in the second graph, in the July month, the race is going only up to 80 seconds, right? So you can say that the race was complete in 80 seconds, okay, in the month of July. And in the month of April, the race was completed in 90 seconds. So the total time in the month of July being less, we can say that the children must have run more quickly in this month of July. So I'll circle this July. Okay. So the reason will be here in July, the children completed the race in 80 seconds, while in August, sorry, while in April, they took longer time, that is 90 seconds. Okay. So 10 seconds they were quicker in the month of July. Okay. So this is one of the reason. Now there can be many other reasons that you can write. Like you can go for the modal frequency also. Now see, this is the highest frequency in the month of April when they participated in the race. It was 12. Okay, so the modal frequency for this is the highest frequency, isn't it? So this highest frequency corresponds to 70 to 75 seconds, right? So this another reason also you can give, and for this the highest frequency is 13. Okay, and this corresponds to 60 to 65. So this can be another good reason that also in July race, in July, the model frequency is that class interval for which the frequency is maximum. Okay, so in the July, the model frequency was 70 to, no, July May it was 65 to 70, right? It was 65 to 70. Okay, not model frequency, you can write model time. Okay, model time was 65 to 70. Okay, with frequency was 13, isn't it? And in April, the model time was, I think in April it was 70 to 75, right? Yes, April it was 70 to 75, and the frequency was 12. Okay, so this was the highest frequency, 13. So this represents the model time corresponding to highest frequency. And in April, the highest frequency was 12. So model time corresponding to this 12 frequency is 70 to 75. So can you see here 65 to 70? This is a lesser time compared to 70 to 75. So in April, in July, they were quicker. So this also is one of the reason. Okay. So the model time will tell you if the model time is less, that indicates that they were running faster. If model time is more, it means that they were not running that quick, okay, that fast. So these two reasons, one and then these two reasons are enough, right? Now let us go to next question. That is question number 24. And here, what they are saying is Bilal wishes to travel from Eastport to Gordontown. Okay, and he can choose between two routes. So this is Eastport and this is Gordon Town. So you can travel from year to year by two routes. So this is one route and this is another route. So route A is the direct route. So this is the direct route A, and route B is going through Timton. So Timton is over here. So this is your route B. Okay. So route A and route B is clear to you. Now the distance of each route has been shown on the diagram. So route A ka distance is 90 kilometer. Route B ka distance is 48 kilometer from your East Port to Timton, and from Timton to Gordonton again it is 72 kilometers. So these are the distances, right? Now if he travels on route A, he can travel at an average speed of 40 km per hour. And if he travels route B, he can travel at an average speed of 50 km per hour. So the speed is also given for both the routes. Work out the difference in minutes between the journey time using the two routes. So suppose he travels through route A. So the time required, TA, for the journey will be, time will be equal to distance upon speed. Okay. So A is representing the route. So TA means the time required to go through that route A. DA means the distance of that route A, and SA means the speed of the boy when he's traveling through that route A. So distance A is given to you as 90 kilometer, and speed is given to you as 40 kilometer per hour. Okay. So this will give you the time in this case it will be 9 upon 4. Okay, I'm keeping it as it is in the fraction form, but this will be hour. Okay, 9 by 4 hour. Now let us convert it into minutes. So it will be 9 by 4 times 60 minutes. Okay, and this works out to 15 fours are 60, and 15 into 9 works out to, I think, 135. Okay, so if he travels through by this route A, it will take 135 minutes. Now same way, let us try to find out the time required to travel if he goes by this route B. So TB will be equal to DB. Now here DB, because it is he is traveling from Eastport to Timton and then to Gordon Town, so there will be total distance. Okay, the total distance traveled upon the average speed from the route B. Now total distance will be 48 kilometer plus this 72 kilometer. So it will be 48 plus 72 kilometer, and the speed for this route B is given as 50. So I will divide by 50 kilometer per hour. Here again I should get this as 8 plus 2 is 10, so 0, and then 4, 7 plus 4 is 11, and 1, 12. So 120 kilometer times 50 kilometer per hour. Now this kilometer cuts, and you get the answer as 0, 0 also cuts. So you get the answer as 12 upon 5 hour. And if you want to convert it into minutes, it will be 12 upon 5 into 60 minutes. So 12 and 60 will go 12 5s, and 12 into 12 is 144. So the answer will be 144 minutes. So if he travels through the path A, route A, it takes 135 minutes. And if he travels to the route B, it takes 144 minutes. The question asked is work out the difference in minutes between the two journeys. Okay, between the two routes. So obviously the answer will be the difference in time will be 144 minus 135, and that works out to 9 minutes. Okay. So the answer will be 9 minutes, right? That was question number 24. Let us move on to question number 25. Now question number 25 is pertaining to some sequence questions. Okay, so let us see what the question says. Now the question says that the position to term rule is multiply by 2 and then add a 3, and you have to complete this sequence. Okay, so there are 4 terms in this sequence, and the position will be, see, position is n, and n, this is first position, second position, third position, and fourth position, and these are known as the term value. Okay, t is the term value. You have to find out the term. Okay, and the relation between the position and the term, that is n and t, is given here. Multiply by 2 and add 3, so t will be equal to multiply by 2 and then add 3. So you have to multiply n by 2, so 2n plus 3. So this is the general formula for this sequence. T is equal to 2n plus 3. So if you want this t corresponding to 1, 2 into 1 is 2 plus 3, so this will be 5. Then for 2, it will be 2 to the 4 plus 3, 7. For 3, it will be 3 to the 6, 6 plus 3, 9. And for 4, it will be 4 to the 8, 8 plus 3, 11. So this is your sequence. 5, 7, 9, and 11. Okay. So, yeah. So that's the answer. Okay. And now, B part of the question is, the third term is 17. The term to term rule is add 5. So now these are the terms. Okay. So these terms are, this is the first term, second term, third term, and fourth term. He says that the third term is 17. So here I am writing 17. Okay. And term to term rule is you have to add 5. So 17 may, if you add 5, 17 plus 5 will give you this fourth term. So it works out to 17, 18, 19, 20, 20, 22. The fourth term will be 22. And this should be, this plus 5 should give you 17. So 17 minus 5 will be 12. So 12 will be this term, and 12 minus 5 will be 7. Okay. So you have to add plus 5 to each term to get the next term. Okay. So 7 plus 5, 12, 12 plus 5, 17, 17 plus 5, 22. So your sequence is 7, 12, 7, 12, 17, and 22. Right. So that was question number 25. Question number 26. A farmer wants to grow, uh, okay, he wants to grow, uh, he wants to sow seed on the field with an area of 120,000 square meters. He needs 10 grams of seed per square meter. So the question is, 10 gram seed is needed for every square meter, so 1 meter square of field. And he has field which is 120,000 meters square. Okay, so how much seed will be needed? So let us first calculate the amount of seed needed. Okay, and then we can calculate the cost of the seed. Okay, at the rate of $0.40, right? So first let us calculate how much seed will be needed. So the seed needed will be 120,000 times 10 gram, which is 120, 1, 2, 3, 4 grams. Now in kg, if you want to write, it will be 120 and then 1200 kg. So this many seeds are needed. Now 1 kg of the seed cost 0.40. So now again 1 kg ka cost is $0.40. Okay. What will be the cost of 1200 kg? Isn't it? This is what he has asked you to find out. So the cost of 1200 kg will be 1200 times 0.40, which is equal to 1200 into 40 upon 100. This 0 goes, this 0 goes. So it is 12 into 4 is 48, and this 0 for 480. So $480 should be the answer. So dollar will be 480. This is the cost of the seed that the farmer will have to bear. So that was question number 26. Let us move on to question number 27. It says that the graph shows the cost of gold in dollars. So the cost is on the y-axis and the mass of the gold is on the x-axis. So it's obvious, if you go for more mass of the gold, the cost will be increasing. So you can see here that this is a straight line graph passing to the origin. Okay. Now the question is, use the graph to find a formula for the cost of the dollars, that is C, of G gram of gold. Okay, so he wants you to make a formula connecting the cost and the graph. Okay, the mass, the cost and the mass of the gold. Now this graph being a straight line graph passing to the origin. So let me explain you. Uh, Straight line passing to origin uh, implies that the y quantity is directly proportional to x quantity. Okay, so here in this case you can say your y may you have cost is directly proportional to your g, that is the mass. Okay, so you can take this way. Okay, now if you try and the equation of this line is y is equal to mx, because it is passing to the origin, there won't be any y intercept, so there won't be any c. Okay, so y is equal to mx, this is the formula. So taking this y ki jagah pe if you take c, so c will be equal to mg. This will be the formula, general formula connecting the cost and the mass. But then the question is, what will be this m? So this m is nothing but the slope of the graph. So slope of the graph, how you will find out? So you take this point 1, and what is the corresponding uh, y coordinate? So 1 goes to 45. So you get this 1 comma 45. Okay, that is this point. I'm talking about this point. Okay, this is 1 comma 45, and if you go to this point, this is 2 comma 90. Okay, so if you take these 2 points and if you try to find out the gradient of this line, so this is another point 2 comma 90. So the m, that is the slope, will be equal to y difference divided by x difference. So y difference is 90 minus 45. So 90 minus 45 divided by x difference will be 2 minus 1. So this works out to 90 minus 45 is 45, and 2 minus 1 is 1. So 1. So this is your slope. Your m is this. So in this formula, if you put m value, you'll get c is equal to 45 times g. So this is the formula. Okay. So c will be equal to 45 g. Okay. 45 times g. So this is the answer for the question number 27. And now coming to the last question of this paper, that is 28. Now this is a question based on transformation. He's asking you to describe fully the single transformation that maps triangle A onto triangle B. So this is triangle A and it is transformed to triangle B. So you have to name a single transformation. So suppose this triangle A, if I take as a sorry, I have a bad throat. Suppose you take this as L, M, and N, right? This is the triangle A, LMN, right? So if you see this LM, so this LM is getting rotated by 90 degree, and this is what is being formed. So this is my L dash and this is M dash. Okay, so L ka image is L dash and M ka image is M dash. Okay, you cannot call it image, but you can say that after the transformation, L becomes L dash and M becomes M dash. And of course, this is N, so this will be N dash. Okay, so these are the vertices of the two triangles A and B. Now, what is happening? LM is getting converted to L dash M dash. Okay, so it is clearly you can see that LM is getting rotated. Okay, by 90 degree. Okay, now let us see what happens to this uh, ln. Okay, now this is ln, right? So ln is vertical right now, and here in the triangle B it has become horizontal, l dash n dash. So again this is telling you that the ln is getting rotated by 90 degree. Okay, and this is getting rotated by 90 degree in the clockwise direction. The first thing about this single transformation you can write is rotation. Okay. Second thing you can write is in the clockwise direction. Third thing you can write is how much it is rotating. It is rotating by 90 degrees. Okay. So this is telling you that the triangle A, after rotation by 90 degree in the clockwise direction, will give you triangle B. So this is that single transformation which can describe how A is getting converted to B. But then one more important thing, this is only the uh, the transformation ka one parameter. The other parameter is center of rotation. Now what is the center of rotation? Now center of rotation is always given by joining the corresponding points of the two figures and taking their perpendicular bisectors. Okay, and where these two perpendicular bisectors meet, that happens to be the center of rotation. So if I join L and L dash, okay, and if I draw the perpendicular bisector of this L L dash, it will be this line, the y-axis. Okay, and if I take this M and M dash, so can you see this M M dash? Now let me do that for you. Okay, so what I'll do is I will, now I'm going to use a black ink. Okay, so if I join this L L dash, okay, and the perpendicular bisector of this L L dash will be this. Okay, the perpendicular bisector of L L dash. Now what I'll do is I'll join M M dash. Okay, so when I join M M dash, okay, uh, uh, M M dash. Okay, so if I join M M dash, okay, the perpendicular bisector of this M M dash will be this line. Okay, this one. Can you see this line? Oh, this is M M dash. Okay, and now I'll draw perpendicular bisector of this M M dash. Okay, so it will be this line. Okay, right. So can you see these are the two lines? These are the two perpendicular bisectors. Okay, this and this one. Now these two perpendicular bisectors are meeting at this point. So this is the point of this is the point which indicates the center of rotation. So your center of rotation is, now this point is 0 minus 1. It will be 0 minus 1. So this is your final answer. Okay. So both the parameters I have given you, the center of rotation as well as by how much degree it is rotating and the direction also. The amount and the direction also I have given you. That was question number 28, and with this I come to the end of this paper. So paper 111202 of October November 2016 has been completely solved. And if you like this video of mine, please subscribe to my channel. And that's all. See you in the next video. Bye. Take care, all of you.